Welcome to this demo of using Apache Spark with the CERN Swan notebook service. We'll be running our notebook, which is a physics use case of computing a histogram of the muon mass spectrum using Spark and attaching to cloud resources via Spark. So the first thing we want to do with Swan is to start a new session and define the software stack. For this I'll be using the very latest Spark, and I will be using the Cloud Containers cluster. So the Spark executors will run on Kubernetes. This demo can also run on Hadoop, that will be the general purpose analytics cluster, or can also run on just a driver in local mode. But here we'll be running on Cloud Containers. So we start the session. Now the Swan session is being allocated. This will be our driver for Spark. Swan itself is running on Kubernetes. Okay, we have here our projects, the Spark training, cloned by from the GitHub repo. So we go on the notebooks and we open this one, the demo of the histogram of the muon mass spectrum. This is high energy physics notebook, and we'll be reading data that originally was processed using the root framework and also originally was in the root format. It has been since converted into using Apache Spark for the datasets and using the Spark data frame API for processing. It's a very simple processing, as you will see. Okay, our notebook is ready. So the first thing we want to do is to connect the cluster. So we'll be connecting to Kubernetes resources. So Spark can run on Kubernetes, and we have a Kubernetes cluster on the CERN cloud allocated for the purpose. There are a few additional parameters that you can see here, and we can just start our Spark session. So one now with the Spark connector is creating for us a Spark session, so contacting Kubernetes and getting the resources there. This takes a few seconds. Okay, we have our Spark session. We are using this version of Spark, and then we have also links to the history server if we want to see the performance of the Spark jobs. Okay, we go to the notebooks, and here the first cell is only used when you're running on local resources. So if you want to run this on a different notebook server, here we use the integration between Swan and Spark to allocate the Spark session. So we move on. Let's see our Spark session that is called Spark. It's on version 3.3.1 and it's running on Kubernetes. So the executors will be allocated on Kubernetes. The driver is here local to Swan. Then there are different modes of running this notebook. You can run locally, you can run on various, also on Swan locally, or on your own resources. You can get the data if you are external to CERN with this wget command. And for running on this configuration, we'll be reading the data from a storage system called EOS, which is used at CERN, and for which we have a special integration where we see the storage system with the root column prefix. Okay, I'll be running this. This will be trigger the execution of defining a data frame and also counting the number of events, so number of rows into this data frame. That is a Parquet file. Here, once I trigger an execution with Spark, there is a Spark monitor, an extra integration which is available in Swan and also available externally if you want to install it in your system, where you can see the job progress and how many executors are there, how many cores. Okay, so we have about 6 million rows into this 61 million rows in this data set, and we can explore it. Let's take the first 10 rows. There are various details so how many muons are in each event. So each row is an event. Event has something that comes out from the collision of protons in LXG. And then we have number of muons, the and then the physics characteristics of this muon, Pt 8 times 5, and the muon mass and the muon charge. These are typical parameters used in physics analysis. This is very simplified. The real-world data set and analysis will have many more characteristics, many more particles, and many more parameters. So for our purpose, we want to have events where there are two muons, and the two muons need to have opposite charge, and we define this with a filter using the Spark API for data frames. This was very quick because Spark uses lazy execution, so nothing really has happened yet. Then we define the computation of the mass of the muon system using formula from special relativity. You can see here the links on the details where this formula comes from. And then we want to do a histogram. That is our final objective. We define the histogram using the data frame API, in particular using a group by, and using the special function width bucket that is available in Spark data frame API and Spark SQL as well. Okay, so we have the data frame, and now we trigger the computation. So we take the data frame with the histogram and we fetch it into a pandas data frame, because then we will use that for plotting. Execution is running. We can see the progress of the execution, and then how much time it takes for each job, and the final time that it took for the full computation. Okay, we have the data, and then we can run this cell that will just plot the histogram. And here is our histogram, where we have the muon mass on the x-axis, and on the y-axis we have the number of events. It's a logarithmic axis, and then we see peaks corresponding to particles and resonances. For example, this is the Z particle. Okay, this takes us to the end of this demo. Thank you for watching.